Hello everyone, and welcome to the online webinar for the course R for Business Analytics. My name is Alari Varmann, and I am the teacher for this course. Are you excited to learn the best business analytics software in the market? I am very excited to teach this course to you, and I hope that you will have a lot of good time going through these practical problems and getting your skills to match the career and industry needs. So let's get started. Firstly, I present some information about me. So as I said, my name is Alari Varmann. My nationality is Estonian. Estonia is a small country in North Europe, just close to Finland. I have graduated from the top science high school in Estonia. This gave me a good background to start out. And my degree and my scientific background are in the following areas: physics, mathematics, programming, and data science. I have around 7 years of teaching experience. I have given online lessons in all these fields that I just mentioned. My academic experience through schools is outlined here. So I have studied in Tallinn Secondary Science School, Tallinn University of Technology in Estonia, Uppsala University in Sweden, and Helsinki University in Finland. All this experience has given me the tools and skills and perseverance and perspective to get really good results in data science, and I wish to convey what I have learned to you in this course. Furthermore, I have specialized in data science in the last 2 years, where I have completed around 15 courses in data science and machine learning. These are some examples of these courses here. As I said, I have been teaching for the last 7 years. I have my own website for teaching, where anybody interested can book a lesson online. So no need to go anywhere, just book a lesson online and we can have a cloud session, for example, on programming fundamentals, solving your mathematics projects, physics projects, or getting started in data science. So this is my teaching. Now let's get introduced to the course. So the course name is called R for Business Analytics. And the outline is brought here on the right. The course consists of 4 chapters and a capstone project. So the first chapter will get you introduced to R and basic operations and functions. The second chapter will teach you how to get your dataset and load it into R, then clean it and transform it to be in a suitable tidy format so you can easily visualize it. Visualization emphasis is in the third chapter, where we learn to create static and dynamic dashboards with the Shiny package. And the main part of the modeling is in chapter number 4, where we learn different machine learning models, where you can make the machine or the program learn from the data without explicitly programming it. And all this curriculum is also outlined on the course website. And the course is definitely practical use case oriented. So the use cases and the practical aspects we learn will help you a lot in doing the capstone project in the last part. So I mentioned the capstone project. So this is an individual project supported by us through the online forums, where you use the New York City taxi dataset to then forecast what could be a taxi trip duration for a specific ride. You have features that you can use to make these predictions and build models. So you will start by cleaning and transforming the dataset, and then building simple models or more complicated models that will then really yield useful results. For example, if you were involved in the taxi company, you would be very much interested in how to get higher revenues, so to get longer duration rides from people. So this is where you can all explore and apply the skills you have learned in this course. Why should you learn R? R is an open source statistical computing platform that enables you to create
perfect and magnificent visual reports, charts, analysis, and presentations. According to the 2016 Katie Nuggets poll, R was voted the best in class business analytics software. This is a very good reason why you should also learn it. So, what companies today are using R? R is used by a lot of companies. For example, Facebook, Google, Twitter, Microsoft. They all use it for different data analytics purposes. For example, behavioral analysis in Facebook, or economic forecasting in Google, or for data visualization in Twitter. There are many more examples. These are just some of the examples. Why should you learn R? There are other reasons why you should learn R also. For example, R has the highest business capability ranking in the class, even better than Python, SAS or MATLAB. And R is also free and has a vastly growing community. There are also other reasons why you should learn R. There are very good career options. For example, I worked as a data analyst in a software development company, and the salaries are often very high, and they are rising because the popularity of the field is growing year by year. And this means that you wouldn't have any employment-related issues in the next foreseeable future. And as well, there are program-specific reasons why you should learn R. For example, there are cutting-edge algorithms are all implemented in over the 12,000 packages. For example, there's a H2O machine learning package that supports deep learning, Keras and TensorFlow. And deep learning is a specific field of machine learning where the neural nets are dense, not necessarily dense, but they're deep, so more than one hidden layer, and they could learn really complicated functions. And gradient boost is another example. It's an algorithm that basically combines different classifiers together to get a very accurate prediction, and this is the algorithm that wins most of the Kaggle competitions nowadays. Kaggle is an environment for data science competitions. So what is data science? You have heard me mention this many times. Data science, or data-driven science, is an interdisciplinary field in which there is always a research question, and then we use data to answer this question. You can see this is an intersection of computer science, mathematics and statistics, as well as domain knowledge. Domain can be, for example, biology or physics or some business domain. You can visualize data science as a pipeline. So the pipeline starts with asking a question. The question is often related to, let's say, company's business situation. And after you have the question phrased, then you need to find data from databases, for example, that then will help you to answer this question. Then you need to clean it, because often it has many missing values, and it's not in a tidy format where every column corresponds to one feature. Then you need to analyze it to figure out what are the most important features or variables that can help you to answer the question and to build a respective model that helps you to get the insight into the problem. And this pipeline here is the first iteration. After you have presented the results to the stakeholders or the company's management, you then refine your question, go back to the start, and start the second iteration. So it's an iterative process. So let us now talk a little about the plotting systems in R. So there are three main plotting systems in R. The first is the base plotting system. You can just run the plot command, and this uses the basic or the base plotting system. Then there is the lattice plotting system. For example, autoplot or feature plot are two examples of the lattice plotting system. And you saw the interactive histogram in the 5-minute demonstration that refers to the lattice plotting system. And the third plotting system is called ggplot2 system. And GG stands for grammar of graphics. And the grammar means that there are 7 basic building blocks that then constitute one plot. So you can build the plot layer by layer and add components as you go. And this ggplot plotting system has been developed by Hadley Wickham, who has also developed the tidyverse package, which is a systematized way of learning or constructing our objects that are all compatible between each other. So okay, now about the ggplot2 system. The first key building block or the component of the ggplot call is a data frame. So for example, if I load the ggplot2 library and use the ggplot2 command, then the data frame is specified in the data equals. So MPG is now a data frame, is a specific object that then is the data type here. And in the second block, we have the aesthetic mapping. So the aesthetic mapping, which is acronym is AES, specifies what we are actually plotting in the ggplot2 call. The third building block is geom. So until I have added any geom objects to the plot, there are no objects in the plot. I just have specified the mapping and the data. But now when I add the third layer, the geom, G, so I use the previous layers plus the geom point, then it actually adds points to my plot. So now I could actually see the plot. And the points can also have parameters like size and opacity, and they can have their own aesthetic mapping. So now, for example, front or rear wheel drive have different colors in this mapping. And there is also the fourth building block, for example, which is facet. So I can get different plots for different cylinders, for example, by calling G plus facet trap. So now this does a different plot for each of the cylinders. And I can also use a grid. So if I want to have a matrix plot, then I use the grid. And so much about the grammar of graphics, and we'll make use of this grammar of graphics extensively in this course. So, and if you want to go for a totally customized plot, always choose ggplot2 library. So now let's move on. Now I would like to tell you a little about a very famous statistical conundrum or example, which is called the Anscombe's quartet. It refers to the data set implemented or realized in 4 ways, but having the underlying same statistics. So a little about statistics, there's a concept of skewness. For example, you know that the normal distribution has equal amount of data on the left and on the right of the mean. But if you have more data on the left, then it's called positive skew. I like to think about that positive side is more empty or has actually less data points. And then similarly you can think the negative skew, then the negative side is more empty. So this is in the case of discrete bins, but you can also have the same with continuous bins. So in this case you will have just a continuous shape, so I have a density shape, but again the positive skew refers to the positive side, has less data points, or so to say longer tail than the negative side. So now let's get to Anscombe's quartet example. You see that we have 4 realizations of a data set, all fit with a blue linear regression line. If you go down, you see that the mean, which is in the 4th line, is always around 7.5. So the mean, we are now studying the y variable, which is the dependent variable, always has the same mean. What you see is that the minimum between the different data sets are around the same, but the maximum is changing from 9 to 12. The minimum is actually from 3 to 5, so it's around the same difference. But you see that it is very different how the maximum is placed. For example, in the last 2 data sets, the maximum is with the maximum accent, and in the third one it's around in the middle, but it's still around 12. So why is this example so interesting? Let's see. For example, could you tell me what could be the standard deviations be? So standard deviation is then the square root of the expected square differences between the data and the mean. So what could be the standard deviations? It's SD command in R. Turns out that the standard deviations are exactly the same in all the 4 cases. Very interesting, right? So could you now tell me what could be the skewness of the y variables be in each of the 4 cases? So the cases are here. Okay. So the answer is that the last 2 cases had positive skew and the second one had negative skew. Let's see. The last 2 cases have positive skew, so it means the positive side of the y variable is more empty. If you turn your head to the left, and you see there are more data points on the left than on the right, on the y-axis. Or meaning that the top is more empty on the last 2 cases. But in the second case, you can see that if you take the whole domain of the y from 4 to 12, the left side again is more empty, and the right side, so actually we use the domain here until 9, but the right side is more dense and the left side is more empty. So we have a negative skew. And now if you look at the first case, you see the skew is actually practically 0. Now let's take a look at the same example in R. Firstly, if you don't have stats and ggplot2 packages installed, then you can go to the packages tab, go there and look for ggplot2, and same way for stats. And if you don't have it, then you click on install. Otherwise, you can click on the left to tick and then load it to the library. So if you load the stats package, you will get automatically the Anscombe quartet example in your workspace. So let's now analyze this example. So first run the summary command, and you see that we get the output of the data here on the left. And now we can attach it to our workspace. We don't have to run the Anscombe command all the time. And now let's, for example, see what is the length of the x2 variable. We see it's 11. What is the length of the x3 variable? We again see it's 11. So most probably, since it's the same data set, we have 11 different points, but 4 realizations. So now let us bind the y variables together. So we use the data frame command to bind these y variables together. I'll show you why we did it. We did it so that we could get the standard deviation of these y variables using this fun equals st, so function equals standard deviation command. So let's now run these commands, and indeed we see that the standard deviation for each of the cases was around 2. Now we would like to create factor levels so that we could separate out these 4 cases in the same data set. Let's call the variable my group, and let's generate factor levels using gl command. And the first number is how many levels, and the second is how many amounts of total we have, how many data points. And we call it as many rows we had in the Anscombe data set. Okay, so the next thing we would like to do is now modify the data formation a little bit, use the same Anscombe's data, but now we would like to create a data frame in this way, that we combine the x values together here, and we also combine the y values together, like this, with a concatenation operator. And then we can use the group as the my group, which we just created, and run this command. Okay? You can also take a look at the header of the data using head command. So now we have only 2 variables, x and y. So we concatenated all the different realizations into the same variables. Okay, so let's see. how many unique cases, for example, do we have in this data. Use this command, and near zero var, it shows you how many variables are close to zero and how many unique cases do they have. For example, see that almost all y variables are unique. So x obviously is not unique because we have around 4 cases, so up to about 25% are unique. But we see that there's also one duplicate in the y. We can, for example, find it by using the which command. Which and then duplicate it, and which of those was duplicated we can see like this. Shows you the 37th entry is then duplicated, and then you can get it like this. And you see that was that x equals 8 and y was 8.84. Okay, let's now visualize this result in the ggplot library. Again, just to make sure you have it loaded, you can always call library on the ggplot2 input. And let's now create an object like this called g, and use the my data now to visualize it. And let us specify the static mapping to be the xval and y coordinate corresponds to now the y val that we just created. And the grouping variable is now the my group, which we just created. And let's see what we get. And now run this str command to see the structure of this object. Sorry. Aha, we see that is a list with a lot of parameters. There's facets, themes, mapping, scales, data, layers, all this kind of layer by layer building that we just talked about in the lesson. So we would like to now add some points to the data set. How do we do this? We build a plot layer by layer, so we just add a geom point object to this G. And let's see if we get something out. Aha, so we see that we got a plot, but we realize that we have concatenated all the cases into the same case. So we have all the x's are in the one feature and all the y's on the other feature or the other axis. But we would like to separate them out by the group. Do you remember what was the command that separated the plots out by group? Yes, it was the facet or the facet wrap or the facet create command. So let us do like this. Use the G that we just had, actually, which is, and then override it. Go press up arrow, so you get the last command back or from the history, and override first G. So G is now overwritten, and now let's add the facet wrap to this. Facet wrap, and for each group we would like to get the different plot as each group corresponded to a different case. And let's also add a title. So we see the result here on the right. So after we have run the facet wrap command, we will get 4 different plots. First case, second case, third case, and fourth case. And if you have any problems with the ggplot saying something about that all variables need to be in one layer, then just run all the commands again from the start, and it should go away. And now we'd also like to see if we could quickly do a quick linear model. So let us run this kind of command. Geom, add the geom smooth object to the G with a method lm called linear model. And let's see what we get. See now the g.lin output looks like this. Aha, so we see we get linear regression lines for each of the plots. But you see that since, for example, we have outlier here on the top, the uncertainty increases on the right. So the shaded gray areas are uncertainty intervals. And now let's see what if we try to do a non-linear regression, because obviously not all data points seem to have a definite linear trend. So run the same command, but now use method equals less, so it's local non-linear polynomial regression. and let's see what we get. Aha! We see that in the last case R even couldn't fit data with polynomial regression. So it's an amazing example how constant statistics doesn't now mean that we can model the data in a very straightforward way, because all the fits of the linear trends, the linear fits are all with very different qualities. In some cases we cannot even fit non-linearly, and in some cases the non-linear fit is perfect. And all these realizations are exactly the same mean and exactly the same standard deviation. So this was an example of Anscombe's quartet. Let us turn our attention now to visualization. We have here visualized Diamond's dataset interactively. You see, as I hover my mouse, I can see the values of cut, carat and price interactively. So I know that the shape of the diamond pretty much shows what kind of cut quality it has. And ideal cuts and fair cuts and all have different shapes. And I can also see that I have different classes have different regression color lines. So the smoother lines are different for each of the cut quality types. Okay, so how did I create this type of plot? It's actually very easy. So how we do it is like this. First, load the ggplot2 library. Then we use the Diamond's dataset. After that, we use the qplot command, which creates a quick plot. Let's plot the carat versus the price. So price on y-axis, carat on x-axis. And use the Diamond's data. And let us shape the plot by cut. And also use facets. Facet is pretty much we can get different plots for different variable type, and here we use the variable clarity. And then use tilde and dot, which means that we get different plots for each type of clarity. And that's it. And you can see the result in Q. Okay, so this is the base plot onto which we can build more additions. So for example, we can now create a regression line that will then smooth the results for us. So let's write jump smooth method equals linear model, so it's linear regression, and let's also color the results by their cut. So that wasn't so hard at all, was it? Alright, so this is how to quickly see what's inside the Diamond's dataset. But this is not all. So there are many other ways to visualize the Diamond's dataset. And here there's an example of a deployed Shiny application, which firstly lets you to choose the amount of diamonds you'd like to see. Let's say that I want to say around 1,000 diamonds. And I visualized the cut as a function of carat. So here we see that I have many more diamonds with smaller carats. And since a cut is a categorical variable, all the data points are basically clustered up on the same line. So to be able to see how many of those diamonds we actually have here, we add the jitter parameter. You see, now it kind of randomly shifts up and down some of the data points, so we can see how many are there in this domain, for example, around 0.2 of the carats. And let's say we'd like to color diamonds by clarity, for example, and let's say that we'd like to visualize the dependent variable as the price. Okay. Let's say that price is on x-axis, and that we have, for example, carat on y-axis now. So we get this kind of continuous plot. And let us now explore if you can have different types of facets. So we're using up price, carat and clarity. So let's use the the cut here on the facet row. So we see that we get different types of, let's say, we have only a few diamonds that are cut fairly, and a lot of diamonds that have, for example, got very well premier or even ideally. So you can see that we can have different combinations of plots. We can have even a matrix plot. So and then we can even add smoothers on top of the plot, and so there are a lot of options how to get something useful out of the data. Let's now imagine that we have a company that has created an email campaign and wants to visualize how were the results of this campaign. And we can use again the ggplot library for that, and the R visualization for this campaign would look something like this. So you can see that we have a plot that looks very similar to a population pyramid, where the most abundant layers are the bottom ones and the more scarce layers are the topmost ones. So for example, around almost 15 million males and almost let's say 13 or 14 million females browsed the campaign, but only around 7 million or so clicked the buy now button from males, and accordingly also from females. And also even less, let's say around 2.5 million made any payments. So this is a quick way then for a company to analyze what you could really focus on, because you see the bigger the difference here, this means that it was the click-through rate or the click probability decreased exactly in this step, so you could then direct more attention to this step. Let's say I can see that there were really more browsers and we have a few less million unbounced users. Let us now turn our attention to analyzing a specific example. Let's say that you are a startup founder and you would like to create a health startup that gives people advice how to improve your mental health, because you know that there are many people who are worried about their future or a little depressive, and you see that the doctors prescribe drugs don't work. So what could you do? You could firstly collect data before you give any recommendations, because if you have data sets, then it's just a matter of knowing the right type of approach and algorithms that work. So let's say that I'm now a user and I enter the website and I'm worried about my health. Let's say my name is Mike and I'm 20 years old, and for example, the first type of questions you could ask: how many hours do you sleep, Mike? Let's say Mike sleeps only 6 hours per day, works 5 hours per day, studies, let's say also 8 hours per day, hobbies, 3 hours per day for hobbies and 2 hours with friends. And Mike is very organized. There is no time that he's doing nothing. Now I can see quick visualization of a pie chart. Let's say Mike lives alone and consumes cigarettes. So this data you would all collect to use as features in your prediction or your recommendation engine then. And then Mike wants to store the data. Now he could have stored his data in Dropbox in a file. And then he could fill in that he's a little sad but has a lot of lack of interest, feels worthless somewhat, let's say too, accuses himself sometimes, and has some suicidal thoughts, and what the other features here are. And then in the last step, Mike presses on get your mood recommendations from algorithm. So this is the step where you utilize the algorithm you have customly written and then give users some feedback. But of course, in the first users, you first need to collect some data from them. So this is one good example. As a next example, we have New York City taxi rides. So remember we talked about the capstone project, in which we said, well, we would like you to analyze and predict how long a New York taxi trip lasts. So for this purpose, I can write a Shiny application and then visualize the results. As you see here, fast trips are indicated with red and slow trips are indicated with green. And these colors represent then different pickup points for the taxi rides. Because company, of course, is interested in where the taxi ride is picked up, then you will know how to place your taxis. And for example, how it works, you can choose different layers for the map. You can zoom in, zoom out, and let's say that you want to know more specifically where in Manhattan the rides take place, then I can zoom into one green dot, and I can even see more specifically even house to house number accuracy. But when you zoom out, then you can see the whole map and all together. So this is an example what you can quickly do in R, and it's not even so hard to do at all. All you have to do is know one library. Okay, so let me once more remind you how you can register for this course. So this course you can find the following way. Go to beatest.in, then click on Get Started, then go to the left, click on Data Science, and then you will see a window on the right which is called R, Business Analytics with R. And then you can download the brochure here, and you can also register for the course there. So this is how you register for the course. And so this is it. This is the end of my presentation. Beatest and me are looking forward to seeing you in the course. So we really think and believe that this course will give you the necessary tools to take your career in analytics to the next level, and hoping to see you all in the course. Thank you.